Contents, just as we mentioned before, a high look at remote condition monitoring and a quick starter with about Senveive. So Chris, do you want to start it off with about Senveive?
Yeah, definitely. Kind of 3 or 4 key points there. So for those that aren't familiar with Senveive, we were founded in the UK, based out of London, 2005, and actually we were originally a spin-off, and a spin-out from a kind of highly reputable engineering research university, the University College London. We've maintained a headquarters in London, UK since then, and obviously have kind of built on some amazing technology and IP from the outset. Principally, we are in the business of the design and manufacturing of remote condition monitoring solutions, and more specifically and pertinently for Senveive, we specialize in wireless remote condition monitoring solutions. A lot of different hardware and then the kind of supporting software and infrastructure that goes with these sorts of solutions. The journey's been a fantastic one for Senveive. We're started in a lab in London 15 years ago. We're now kind of operating across 40 different countries, at least at the moment, systems deployed in 40 plus, kind of nominally identified by the green dots. And what is nice is that we've now got 3 flagpoles down across the globe. So the pink dots, the kind of looking at obviously the London HQ, and then we've got a R&D office down in Perth, Western Australia, and kind of more recently we set up shop in Dan's backyard in Brooklyn, New York. So yeah, we have a presence and a foothold in North America, and we expect to kind of have more flags cropping up as the business continues to evolve. And then finally, in terms of where we focus and what we spend our time doing, we are pretty much exclusively and razor focused on 3 key markets: civil engineering, infrastructure, and the construction activities around that. Rail, it's very parallel to kind of civil engineering and infrastructure, but rail is a specific discipline we have a lot of activities in. And finally, mining goes hand in hand with civils, and our technology is definitely more than suitable, very applicable to both boards, mines, and open pit mines.
Great, thanks, Chris. So yeah, let's dive right in, starting with what is remote condition monitoring. So first and foremost, it's the physical use of sensors installed on some structure or element, for example, the inside of a tunnel, as shown here. With these sensors, we are transmitting data wirelessly through on-site telemetry and then sent to a remote server via cellular network, Ethernet connection, or even possible via satellite communication. So then to perform continuous measurements of parameters that the specific sensor is capable of. With remote condition monitoring technology and the advancements we've made with efficient power usage, measurements can be taken at high frequencies while still operating for years on small batteries. Shown here in this photo are triaxial tilt sensors installed on concrete ties where they are performing continuous track geometry measurements, while, as you can see, a survey team is on site for baselining that sensor's position. Remote condition monitoring is unmanned and automated, allowing users to understand what is happening in areas that are heavily populated or remote, like the example of this triaxial tilt sensor installed at a reservoir site. So it's important to note that by deploying an unmanned and automated system, you're able to reduce on-site labor, which is both a safety consideration as well as a cost-effective monitoring method. And of course, it is this method to detect change from some baseline or initial position from the time of install. Change detected can be used to adjust, for example, maintenance schedules, adjust construction methods, or to understand more hazardous movements that can pose a risk to people's safety, like this section of rock along the cliff, which is being measured for displacement and tilt. And on to Chris with the why.
Yeah, onto the why. So why do we deploy remote condition monitoring and remote condition monitoring solutions? Well, kind of 4 points to cover here. First one, the protection of assets and investments. Infrastructure is expensive and often, designed to last a long time, but also has many other neighboring forces in play that would require sensors and sensor systems to be required. And kind of on top of that, and to do with protection, if we're talking about particularly new construction, then the big insurance firms that underwrite major infrastructure or civils projects, they typically want to reduce their risk as much as possible. And monitoring and collecting that data and understanding how things are interacting and behaving is a risk reduction method. So we typically find that insurance companies are also very, very powerful in defining and demanding that monitoring, and therefore in many cases automated and remote condition monitoring, be used on civil and earth and infrastructure. Second one is kind of reduction of whole life monitoring costs. So specifically, if we're talking about remote and automated condition monitoring, as opposed to say manual or kind of periodic monitoring, in some scenarios where access or scale could demand a lot of resource heavy activities, therefore perhaps manual monitoring becomes very cost ineffective. The investment, the capex investment in a sort of remote condition monitoring platform solution could actually deliver a reduction in whole life cost of monitoring across that project or that asset life cycle or lifetime. Third and very kind of important point, keeping people safe. Monitoring solutions are in many ways an early warning system and are, quite commonly deployed on sensitive or possibly possible structures of concern that pose a risk to human and kind of civilization safety. So, they are there to help keep people safe. And finally, the measurement of performance or performance measurement. A lot of structures or a lot of construction, there's a lot of design and theory work that's put in place pre-construction that companies, clients, and engineering firms want to, in effect, compare to during the work. So it's design versus kind of build in terms of is the data in line with their initial modeling and expectations. Onto the when.
Great. Onto the when, exactly. So when do we perform remote condition monitoring? So one of the more common situations is during construction-related activity where, for example, the impact of that activity itself could upset the foundational element of a bridge pier, for example, or shown in this photo to measure the performance of the structure that is being built, and in this case, remote convergence monitoring during a mining operation. Is also used when an asset owner has the need to evaluate its structure for potential repair or replacement. So much of the early construction of our national infrastructure here in the US dates back to around the century mark, when much of that infrastructure was designed for expected lifespans of 50 years. So this has forced asset owners to evaluate whether to repair or completely replace certain structures. Remote condition monitoring is used as part of this evaluation process to provide owners with continuous information around the health of a structure, which can tell them, amongst other things, whether it is stable enough to keep in place with potentially minor repair, or if that structure is in critical condition and requires more immediate replacement. So it's also used in areas that are, well, remote in general by nature. Access difficulties can be due to the nature of where it is located, as shown in this example of a cliff face that would be impossible really to access for physical measurement without some extraordinary budget available to the team. Or for another example, it can simply be in railroad right-of-way, above ground, or in a tunnel where access is both dangerous and disruptive to the railroad's operation. And finally, when a high frequency of readings is simply just required. This can be to understand the more immediate impact of construction on some critical infrastructure while that construction activity is being performed, like, for example, compensation grouting. Or it can be when the remote condition monitoring system is being used as an early warning for catastrophic movement, as shown in this photo where a network of triaxial tilt sensor nodes mounted on stakes embedded into the topsoil of the slope are proactively and remotely monitoring for potential landslide into an active railroad corridor. As I mentioned earlier, I believe in the what is section, the advancements of this technology now allow for these high frequency readings while keeping many years of battery life for minimal maintenance.
Onto the where.
Onto the where.
Yeah. You got me okay? I think I've rejoined the main session now. My computer's decided to play ball. You hear me all right?
Oh, great. Yep.
Excellent.
Great.
Yeah, there we go. I can see the screen as well. Where? Yeah, kind of continuing with the theme. So we kind of got 4 key points around where remote condition monitoring systems could be, should be, and are actively deployed. So the first one is on infrastructure, so either critical infrastructure or nearby infrastructure within a project influence zone. So what we mean by that is typically in new construction projects, the building of a new asset kind of disrupts the equilibrium in the surrounding area, whether that's structural or geotechnical. And part of that, kind of as alluded to earlier, that insurance demand from the underwriters and the protection of neighboring property and infrastructure, monitoring systems are actively deployed on neighboring assets to make sure that they remain safe and structurally stable. Where in terms of physically, we're typically 2 types, both structural, so i.e. on sort of man-made objects, and then geotechnical elements, so either hewed out of the ground or drilled or buried into the ground, looking at the earth, kind of physics and properties as opposed to structural properties, and these can either be temporary works or temporary assets, or indeed the permanent construction assets being put in place or kind of are already there. So both structural and geotechnical, and then either temporary or permanent. You've kind of got a combination of any of those 4 properties really. Third one, engineered structures identified for health assessment. So back to Dan's comment around asset life extension, and the need for monitoring infrastructure that's perhaps past their initial design life, where DOTs or clients decide to replace or add additional infrastructure assets, bridges in this example, next to an existing bridge. They will typically take the opportunity to monitor the existing bridge, keep an eye on its performance and its condition. But we're seeing more and more clients recognize the benefits of those retrofitted systems on the existing infrastructure by installing systems as the new structure is being built, i.e. they get from commissioning a monitoring system that they can then take engineering decisions on from the very start, or the very kind of early stages of a structure, all the way through to any sort of decommissioning we expect in decades or centuries time. And finally, Again, back to that kind of keeping people safe, they're often used in hazardous areas or areas that have been deemed as high risk, whether due to stability issues or construction activities, or just particularly very sensitive areas around on networks. Monitoring systems are used to kind of pick up any early warning signs for major failures. I mean, you'd argue in this case it was probably a bit late, but you know, these sorts of major earthwork failures on rail track embankments and cuttings and any sort of geotechnical assets are very common. Water is and rainfall is actually the railway industry's kind of worst enemy, and you know, there's plenty of rail track around the world in areas where there's a lot of rainfall. So these sorts of failures are common and need to be identified before a high velocity moving train gets anywhere close to these sorts of parts of the track. So very, very common and very typical for high risk and hazardous areas to have automated and remote condition monitoring solutions deployed on them.
All right, and then once the screen loads, sorry, okay. And for the last section, and finally, how do we perform remote condition monitoring? So one of the more exciting parts. So, well, of course, the appropriate solution first needs to be selected. This can be the situation where a project specification has been created and outlines the specific sensor type for each parameter that the owner or engineer wants measured. Sometimes, most of the time, really, in a specification, it's even down to the sensor's own required resolution and reading frequency. Or in some cases, there's an owner who's concerned that their asset is unstable. There's no project specification. This isn't something planned, budgeted for. They really just want to continuously measure that asset to understand its behavior, and even have the desire to receive early warning of sudden movement before or at the time of catastrophe. Probably most similar to the case of what Chris was just showing with the hazardous areas, with the washout below the rail track. So, at this stage, it's always very important to include a monitoring expert into the conversation to ensure that the appropriate solution is being selected, whatever it is, and all limitations and advantages are understood prior to installation. We see all too often that a product is selected based on price, based on relationship, and it may not be the right solution for the application. And this can lead to a lot of frustration down the line, not only with the entity performing monitoring, but to the owner who paid for monitoring to be performed. So once that process is complete, everyone's happy, POs are issued, and equipment's received and tested, it's on to the installation. So since there are so many different remote monitoring solutions on the market, and even more application of these solutions, there will be varying degrees of installation experience and expertise available. So, proper vetting is very important. It's an integral part of this process, not just selecting the right solution, but in combination, also the outfit that is performing the installation. So once the installation is complete, then it's on to what I and others call the commissioning process. So this is where we confirm that all data is being received by the hosting software, and then where that software is set up to properly display and provide data that is in a format that both makes sense and is useful to the monitoring team and the person paying for this data. It is also importantly where data is transformed into engineering units and parameters are set with threshold values if notification of exceedances are required. So, there are varying types of different softwares. There's control softwares which set up and control remote monitoring solutions, and there's also data visualization and management software, which is, normally a nice client-facing software that provides a lot of extra value and insight into that data, what it means on site. So once this process is complete, then it's sitting with the monitoring team, with all involved parties, and agreeing on the big if, then, what scenarios. So if, for example, this movement is detected, then what do we do? Does construction stop? Do we stop train traffic in a certain area? Do we adjust construction methods? All very important considerations depending on the application, because data is only as useful as you make it, and action plans are how you decide what to do with it.